Welcome friends. Today we welcome you all in live lectures, session of our live lectures. Today in our studio we have with us Dr. Pavitra Bharadwaj. Dr. Bharadwaj is Assistant Professor in Jesus and Mary College, University of Delhi in Department of Computer Science. Today we are going to discuss about normalization of databases. Doctor.
Hello friends, in continuation with our lectures in database management systems, today we are going to discuss a very interesting topic, that is normalization of databases. Just a quick recap of what we have done so far. Databases, we all know, is a collection of organized data which is logically coherent. A database management system is a computer software which helps us manage that database, add data to it, retrieve from it, and also does a lot of control, redundancy control and access control functions. There are various functions which we have discussed already. Today we are going to talk about the normalization in databases. Basically we are going to discuss what is the database architecture. We are going to talk about database anomalies. Then we will discuss a brief history of normalization. Normalization, what it is and why is it needed, and we will try and discuss a few normal forms, first, second, third and also the fourth or the Boyce code normal form. Now the diagram here shows the life cycle of a typical database application. Whenever any customer or any company requires a database to be created, there are 4 steps involved in this application development. The first is the requirement analysis, that is the database designers and the system analysts sit together with the customer and find out what are the requirements that they need, for what is the purpose for which the database is required. After this, the next step that comes in is the development of an entity relationship diagram. An entity relationship diagram will basically tell what entities are there in the database system, how they are related to each other and what are their attributes. It is a diagrammatic format so that it can be easily shared with the user or the customer and the feedback can be taken. The entity relationship diagram is then developed into the relational schema. The relational schema is the logical organization of all the entities, of all the tables, their relationship, the attributes which are present in the database. And once the relational schema has been approved, then the implementation phase starts. In the implementation phase, the SQL queries are designed, the data from the customer is populated in the tables and all the other activities related to implementation of the software are carried on. Now, sometimes it is observed that after implementation, the database design was not perfect. In that case, there are some problems in the databases. We are going to first find out what are the problems that occur when a database is not properly designed and how we can rectify these problems using the technique of normalization. So basically ER diagrams can lead to different relational schemas, and which relational schema is the best. So ER diagram will actually provide a big picture or a macro view of an organization's data requirements, and it is created through an iterative process. That is, again and again it is revised as per consultation of the customer, and this is used to identify any additional entities or their relationships in between. So schema refinement basically is a task which is carried on. Now schema refinement tells how the tables can be changed, how they can be updated to form a more coherent, a more non-redundant database. Now I am going to show you 2 schemas and we need to think about which schema is better. So, the first table or the first schema shows one single table which has employee, department, both data together, employee ID, name, department ID and department name, whereas the second schema which segregates the data of the employee and the department, which has two relations, one is the employee relation and the other is the department relation. Now, it is very clear on first look itself that the second schema which defines or which describes it as two relations is better than the first one. Why is it so? Because of two reasons. First, in the first schema which clubs the data of the employee and department, it is actually joining two non-related data items. And second, this relation schema may lead to redundant data. Redundancy basically implies to duplicacy or the same record or the same data item being stored at multiple places. The definition of redundancy is the same data item being stored at more than one place in a database. The main objective of a database designer should be to minimize the redundancy so that the data at any point of time is accurate, is integrated and is consistent. So, in this case there are two problems. First, as I just said, it is going to store the two different ideas together, which is going to lead to a lot of wastage of storage space, and second problem will be database anomalies. Now, database anomalies, basically these are the problems which arise from relations that are generated directly from user views. Sometimes we need to understand that a user may not view the system as logically as the database designer is described to. This can lead to three different types of anomalies in the databases. These anomalies are update anomaly, deletion anomaly and insertion anomaly. An update anomaly is a data inconsistency that results from data redundancy and a partial update. A deletion anomaly is the unintended loss of data due to deletion of other data. Combining information that does not belong together into one table can cause a deletion anomaly. An insertion anomaly is the inability to add data to the database due to absence of other data. Now, in this case we can see that the relational schema which shows employee ID, name, department ID and department name. In this case, first we will see the case of an update anomaly. In case the company decides to rename the sales department as sales and marketing department. So, for every instance where the sales department has noted in the schema, it needs to be updated. If by chance even at one location the updation does not take place, then this is going to lead to inconsistency in the database. Deletion anomaly will occur, for instance, if there is only one employee in any given department and that employee happens to leave the company and go. So, with the deletion of record of that employee, the department record shall also be deleted. Therefore, even if a department will exist in the company, the database will not be able to reflect its record. Insertion anomaly may also occur. For example, if there is a department which is newly set up and there is no employee as such which belongs to that department. In this case, the record for that particular department cannot be inserted into this table unless an employee joins the department. Therefore, we see that when the relational schema is not properly designed, this can lead to three types of anomalies. All these three anomalies may lead to data inconsistency at a later stage or the inability to provide an integrated and accurate view of the data which the user is expecting from the database system. Therefore, the problem can be solved by a process called normalization. So, normalization is the process through which we will reduce this data anomalies, we will reduce the redundancy, and thus we will reduce the possibility, or we will eliminate the possibility of all these three types of anomalies: insertion anomaly, updation anomaly, and deletion anomaly. So, the main goal of database normalization is to restructure the logical data model of a database to eliminate redundancy, one, and second, organize the data efficiency. It will reduce the potential for data anomalies. Thus, we say that normalization is a process that improves a database design by generating relations that are of higher normal forms. The objective of normalization is to create relations where every dependency is on the key, the whole key, and nothing but the key. So, if we talk about the idea of normalization, so it was first proposed by the famous scientist Cord. He defined the three normal forms, and today we have 7 normal forms. In order to do normalization, we must know what the requirements are for each of the normal forms that we will. One of the key requirements to remember is that normal forms are progressive. This means that in order for a database to be in the second normal form, it has to be in the first normal form. Any table to be in the third normal form must be in the second normal form, and in the Boyce-Codd normal form, it has to be in the third normal form. It is also important to notice that the highest normal form sometimes may not be required, because at times the overheads required to normalize the tables are much more than the benefits accrued by the whole process of normalization. So, generally speaking, in the databases are normalized up to the third or the Boyce-Codd normal form. Higher normal forms are only taken in some exceptional cases of database management. For most practical purposes, third or Boyce-Codd normal form is acceptable. So, this diagram shows that the Boyce-Codd normal form is the strongest normal form in the 4 types of normal form, and how the normal forms, they are a part of each other. That is, the first normal form is the basic. For any relation to be in the second normal form, it has to qualify the conditions of first normal form, and the same is true for second, third, and Boyce-Codd normal form. So, we consider that a relation which is in the Boyce-Codd normal form is fully normalized. For practical purposes, this is considered as fully normalized. The benefits of higher normal form is that the update semantics for the affected data are simplified. This means that applications required to maintain the database are simpler. A design that has a lower normal form than other design has more redundancy. Uncontrolled redundancy can lead to data integrity problems. So, before we actually begin normalization, we need to talk about a very important topic, and which is related to the process of normalization, is functional dependency. Now, in the previous lectures, we had discussed the different types of keys that are present in the relations. A key is basically an attribute of the table which defines records, which identifies records in the table. We had discussed the concept of primary key, which is unique and not null, and which is used to identify the records or tuples in a table uniquely. The value for primary key attribute can neither be duplicate nor be null. Therefore, we can say that the primary key attribute of a table can also be used to determine the values of the other attributes. For example, in a table where employee number is the primary key, employee numbers can be used to determine the value of other non-key attributes like employee name, employee date of birth, etc. Which is not true vice versa, because given the same employee name, you cannot give a unique employee number, because there could be more than one employee in the company with the same name. Therefore, it is a one-way relationship where the key attribute determines the non-key attribute, and this relationship is known as functional dependency. So, we say that an attribute B is functionally dependent on another attribute A if for any two records which have the same value for A, then the values for B in these two records must be the same, which implies that for a given value of A, there is one and only one value of attribute B. It is also denoted as A determines B, and it can be written as an arrow marked from A to B. For example, if a company keeps tracks of employee email addresses, we only track one email address for each employee. Suppose each employee is identified by their unique employee number. We say there is functional dependency of email address on employee number, because given the employee number, you can find out the email address. Therefore, we say that employee number determines email address. In this case, the attribute on the left hand side is known as the determinant. Determinant means the attribute whose values will define the values of the other attributes of the table. Now, in this case, this is another table which we are seeing. Here we have employee number, employee email, employee first name and employee last name. So, in this case, if employee number is the primary key, then functional dependencies exist between employee number and employee email, employee number and employee first name, employee number and employee last name. Therefore, employee number is known as the determinant, as it determines the value of all other attributes. Functional dependencies can be depicted in a number of ways. As I just said, the one way is using an arrowhead from the determinant to the determined attributes. It can also be shown in the second way, which is represented here, and the last way, which is also known as a dependency diagram. We are going to use the last way of representing functional dependencies, that is the dependency diagram, in the future normal forms process. So, besides functional dependency, there are other types of dependencies also. For example, a database has a composite key. A composite key basically is a key which is composed of more than one attribute. In this case, we will have attributes which are dependent on the complete primary key, but not a subset of it. What I mean to say here is that the attributes which are the non-key attributes, value can be determined only if you know the value of both the subsets of the primary key. That is, the dependency exists between the complete primary key and not a subset of it. This type of functional dependency is known as fully functionally dependent. Whereas, if there are attributes which are dependent on a part of the primary key, in that case, this dependency becomes a partial dependency. So, partial dependency means the dependency of the non-key attributes on part of the primary key and not the complete primary key. So, the diagram here also shows another example where we see there is two elements in the primary key. One is project number and the other is employee number, and we have other non-key attributes like project name, employee name, job class, charge per hour and hour. In this case, we have two attributes, project number which determines project name and employee number which determines employee name. In order to find out the value for employee name, you do not require the project number, which is also a part of the primary key. Therefore, we say that employee name is functionally dependent on employee number only and not on project number. So, this type of dependency exists, which is known as partial dependency. So, a partial dependency exists when an attribute B is functionally dependent on an attribute A, and A is a component of a multi-part candidate key. Therefore, in this case, actually project number and employee number is the candidate key or also the primary key, but there are attributes in the table which are depending on only a subset of the primary key, only on a part of the primary key and not a complete primary key. So, partial dependencies exhibit the possibility of data redundancies existing in the databases. This is an indicator that the databases are not in a pure consistent form. Next type of dependency that we discuss is a transitive dependency. For instance, there are three attributes, attribute A, attribute B and attribute C, and we say that A determines B and B determines C. That is, attribute B is functionally dependent on attribute A and attribute C is functionally dependent on attribute B. Therefore, we can infer that attribute C is also functionally dependent on attribute A. So, functional dependencies in this case are transitive, which means that we can have the functional dependency of C on A. That is, since A determines B and B determines C, therefore, we imply that A determines C. So, we say that C is transitively dependent on A through B. So, dependency between two non-key attributes is called transitive dependency. So, this kind of dependency is also an indicator that the database is not in a normalized form and there are possible redundancies. Taking the same example, we have project number and employee number as the primary key, project name, employee name, job class, charge per hour and hours is the other attributes. Now, in this case, the attribute job class determines charge per hour and the attribute employee name determines job class. Therefore, we can say that employee name determines charge per hour. Therefore, this is a dependency between non-key attributes, that is job class and charge per hour. So, this type of dependency is called as transitive dependency. So, we have discussed three types of dependencies: functional dependency, that is the dependency of non-key attributes on the primary key; partial dependency, that is the dependency of one non-key attribute on part of the primary key and not complete primary key; and transitive dependency, that is dependency of one non-key attribute on another non-key attribute. Further, we need to understand that functional dependency is a desirable dependency because that will maintain the entity integrity of the database. However, partial dependency and transitive dependencies need to be eliminated from the databases so that the redundant information or data which is stored in the relations can be removed from there. Now, further we will see how this can be done. But before this is done, a graphical notation is used to show the dependencies between attributes of a table. These are used using a dependency diagram. So, a dependency diagram is basically a tool which is used by the database designers so that no dependency is missed and all the desirable as well as undesirable dependencies can easily be showcased. So, in this case the primary key components are shown in bold, underlined and shaded in a different color. The arrows between the entities indicate all desirable dependencies, that is dependencies on primary key, whereas the dependencies which are on non-key attributes or on non-primary key or part of the primary key, they are less desirable dependencies which are shown by lines or arrows towards the bottom of the dependency diagram. So, we can see an example of the dependency diagram. So, this is an example which shows here the same relation in the form of a dependency diagram. As you can see, the employee number and project number is the primary key which appears here as underlined and is in a different color. There is a line joining the two which means that both these are primary keys. Then all the other attributes, that is project name, employee name, job class, charge per hour and hours, are functionally dependent on the complete primary key. So, these dependencies are shown on top of the diagram, whereas partial dependencies between the employee name and employee number, project number and project name are shown at the bottom. Also, transitive dependency between job class and charge per hour is also shown at the bottom of the diagram. We shall be using the same tool, that is the dependency diagram, to further normalize the databases. So, the first normal form that we will take is how to convert a database into the first normal form. So, in order for the table to be in the first normal form, each table has a primary key, that is minimal set of attributes which can uniquely identify the records. The values in each column of a table are atomic, that is no multi-valued attributes are allowed. There are no repeating groups, that is two columns do not store similar information in the same table, and normalizing table structure will reduce data redundancies, and we will be using 3-step procedure to normalize a database. The example that we will be taking for the same is the same as the project employee example that we are studying for the dependency diagram. So, this example, this table shows the same data that we are using, the same relational schema which has project number, project name, employee number, employee name, job class, charges per hour, hours billed and total charge. Now, in this case I would like to draw your attention to a few facts. See, an employee in the project name, that is evergreen, many places evergreen is used, but the name of the project is written only once. Therefore, we can see that there are null values which are present in this. Secondly, the primary key is not clearly defined. Then there are repeating groups also which we can see. For example, for the same employee, the job class has been specified multiple times. Therefore, and because the job class is defined multiple times, therefore, the charges per hours is also defined on each project separately. Although the charge per hour with relative to a job class remains constant, but this has not been done. Therefore, we say that this particular table is not in the normal form and it needs to be normalized. So, we need to see what is required to convert this table into first normal form. Thank you. we were talking about the normal forms. Just to take a quick review, we were talking about the concept of functional dependencies, partial dependencies and transitive dependencies. Functional dependencies are dependencies of non-key attributes with the key attribute, that is the primary key. Partial dependency is the dependency between the part of a primary key, a subset of the primary key and a non-key attribute, and transitive dependency, which is the dependency between two non-key attributes. Now we need to focus on the actual normal forms and the process which is followed for normalization. So we were looking at an example which shows the relational schema where employee and project data is given to us. In this case, we can see that this table has the data related to the project name, which shows null values are there. It also shows that repeating groups are there. Certain information is repeated, like job class, which is related to a particular employee, has been repeated for each project. Also charges per hour, which is related to the job class, has been repeated. Now we will see the steps which we need to follow to convert this normal form, this table, into the first normal form. So the first step which is taken is to eliminate the repeating groups. So present data in a tabular format, which each cell has a single value and there are no repeating groups. Repeating groups basically means that the values in the different columns are the same. Also, we need to check that the atomic values are present and no multi-valued attributes should be there. Now, what is a multi-valued attribute? Basically, an attribute which has more than one value is known as a multi-valued attribute. For example, in this table itself, if we have a column or an attribute called employee degree. Now, an employee can have more than one degree. Therefore, this column of employee degree will become a multi-valued attribute. So, the purpose of the first normal form will be to remove all the multi-valued attributes and to eliminate all the repeating groups. The second step in the first normalization process is to identify the primary key. So, the primary key attribute must be uniquely identifying attribute values. The database designer aims to choose a primary key attribute which will uniquely identify the records, which will be unique and which will be not null. Therefore, once the primary key has been chosen, all the null values which are present in the table have to be removed. One should be very watchful of null values which are present in the database, because that is not the sign of a healthy database. So, the first normal form itself will ascertain that all the repeating groups and all the null values have been deleted from the table. So, once the primary key has been identified, the null values will automatically be eliminated. The third step that is followed is to identify all the dependencies. In order to identify all the dependencies, a dependency diagram is created. So, this dependency diagram will depict all the dependencies which are present in the given table structure. It will be helpful in getting a bird's eye view of all relationships among the table attribute, and it makes it less likely that somebody will overlook an important dependency. So, this table now shows the structure of the table which is there in the first normal form. As you can see in the table, all the null values have been removed and data has been put in instead of the null values. The primary key has been identified, that is project number and employee number together are the primary key now, and for all rows which had null in the project name column, data has been put. Therefore, this table now shows the first normal form. The third step in the normalization of the first form says that a dependency diagram needs to be prepared. We had earlier discussed what a dependency diagram is. It is basically a graphical tool to show all the possible dependencies. So, this dependency diagram represents the table in the first normal form. As we can see in this, there are different attributes. So, the primary key attributes have been identified. They are represented by an underline and a different color. So, this table has a composite key. Therefore, all the desirable dependencies will be on the whole composite key, which are shown on top of the diagram through arrows. Given the value of both the components of the primary key, one should be able to determine the value of the non-key attributes. Then towards the bottom of the diagram, we show partial dependencies. Partial dependency exists between project number and project name, and employee number, employee name, job class and charge per hour. That is, if we are provided with employee number alone, we can still find out the employee name or the job class or the charges that the employee takes for a particular job. We do not require the information of project number to find out the name of the employee or his job class or his charges. Therefore, this dependency is called as a partial dependency. So, partial dependency is shown at the bottom of the diagram. Then in this diagram, the table also reflects a transitive dependency, that is a dependency between two non-key attributes, that is job class and charges per hour. So, this is a transitive dependency between two non-key attributes which is shown here. So, now after looking at this table, after looking at the dependency diagram, we say that the database is in the first normal form. But still it shows a lot of repeating information, a lot of redundant information can be seen in it. Therefore, the database needs to be normalized further, and the second normal form is chosen for that. So, relational database design is further improved by converting the database into second normal form. So, second normal form basically means that the precondition is that the table should be in the first normal form. So, it means that the table should have a primary key which has been identified. There should be no null values in the table. There should be no repeating groups in the table. And if possible, we should be ready with a dependency diagram. When we have the dependency diagram, in the second normal form, we will target to exclude all partial dependencies. That is, no attribute should be dependent only on a portion of the primary key. Now, how the second normal form is achieved? Writing each component on a separate line and then writing the original key on the last line. Then writing the dependent attributes after each new key. At this point, most anomalies have been eliminated. So, in this case, in our project employee example, what we will do is, we will write the last line, in the last line we will write the composite key, that is project number and employee number and hours, and we will create this as a new table. This is an important step because from one table, in this step we are creating 3 tables. So, there existed partial dependencies between project number and project name, So, project will become our first table. There existed partial dependencies between employee number, employee name, job class and charge per hour. So, employee will become our second table, and the third table will be assign table. Assign means that in this table we will have the composite key, project number, employee number and hours. So, in the second normal form, from the first one table that we had begun, now we have three tables: project, employee and assign. And we are also trying to remove all the undesirable dependencies, that is partial dependencies. It must be noted here that there is still transitive dependency which is remaining here. So, in this case we can see the diagram which shows the second normal form. The second normal form conversion we can see now. We have three tables from the first table. The first table is known as the project table, where we have project number which is dependent on project name. Then we have employee number which determines employee name, job class and charge per hour. In this table still we see a transitive dependency is there, that is job class and charge per hour. This dependency will be removed in further. Then the third table which is created is the assignment table, where we have the composite key, project number and employee number, and this together determines the value of assigned hours, that is how many hours one employee has worked on the project. So, the third table uses a composite key, whereas the first and the second table they use a single component, a single attribute key. Now, we will look at the third normal form. So, after we have removed the partial dependency and we have identified the primary key, we have removed the null values, we have removed the repeating groups. So, our table now qualifies to come in the third normal form. So, for a table to be in the third normal form, it is supposed to be in the second normal form and it contains no transitive dependencies. That is, in this case we will have to use the following steps. First, identify each new determinant. The term determinant has been used earlier also. Determinant is used for the attribute which determines the values of the other attributes. For example, the primary key attribute is said to be the determinant attribute. So, in the third normal form, we will try and eliminate the transitive dependency between two non-key attributes. For this, what is done is the two non-key attributes are written separately. So, identify the dependent attributes, name the new table appropriately. Check all the new tables created so far for any undesirable dependency through the dependency diagram for all the tables. So, after this, after the third normal form, what we see is we have four tables now. The first table is the project table, which has project number and project name, where project number is functionally dependent on project number. We have the second table which has employee records, which has employee number. Employee number determines employee name and job class. In this case also, we see that there is no transitive or partial dependency. In the third case, we have created this new table which has job class and charge per hour. This is important to note here because this was a transitive dependency in the second normal form between job class and charge per hour. So, we have created a new table called job, where job class is become the primary key and charge per hour is dependent on it. Therefore, the dependency now has converted from transitive dependency to functional dependency, and our table qualifies to be in the third normal form. The fourth table is the assignment table, which was also created in second normal form, which has project number, employee number as the primary key, which is the composite key, and assigned hours for the project is dependent on the complete primary key. That is, if you want to know the hours for which an employee has worked, you need to give the information about the employee number as well as the project number, because the same employees are working on different projects. Thus, we see that after the third normal form, we have eliminated all repeating groups. The primary key has been identified, the partial dependencies have been removed, the null values have been removed, and in the third normal form, we have also removed the transitive dependency. One important point to note here is that from the one table that we began, the initial relational schema had just one table which had information combined of both project and employee. Now we have 4 tables, one for project, one for employee, the other for job, and the fourth table which maps the information of the employee and the project and the hours for which the employee has worked. So, we see that as a result of normalization, each relation is decomposed into more than 1, more than 2, more than 3 relations. Thus, it is important to note that after each step the number of relations will increase, and hence the database designer has to trade off between the normal form and the reduction in redundancy. Therefore, we say that the objective is to minimize redundancy through normalization. However, a database has to be normalized till the extent that the data anomalies have to be completely eliminated. Now, after the third normal form, there is another important normal form which is generally considered as the most strongest normal form, is the Boyce-Codd normal form, BCNF, or the Boyce-Codd normal form. This BCNF or Boyce-Codd normal form is named after the two very important computer scientists who worked a lot in the database field, Boyce and Codd. Now, in this case, every determinant in a table is a candidate key. We all know this, that all determinants are candidate keys. This has some characteristics as primary key, but for some reason this is not chosen to be a primary key. Earlier lectures also we have clarified the difference between a candidate key and a primary key. A primary key is one of the candidate keys which is chosen to be the primary key. The candidate keys are all eligible to be the primary key because they all qualify the condition for uniqueness and not null. When table contains only one candidate key, the third normal form and Boyce-Codd normal form are same. This is an important point. When we have only one candidate key, then there is no difference between the third normal form and the Boyce-Codd normal form. The database designer will choose for a Boyce-Codd normal form only in cases where there is more than one candidate key. That is, besides the primary key, there is another key which is eligible to be the primary key, which qualifies the conditions of uniqueness and not nullness. In such cases, the database designer will choose for a Boyce-Codd normal form. Now, we need to see that what is the problem which occurs when we have a candidate key other than the primary key in our system, in our relation. So, Boyce Codd normal form can be violated only when table contains more than one candidate key. So, a table is in the third normal form when it is in the second normal form and there are no transitive dependencies. We have seen this, that in the third normal form the transitive dependencies were eliminated. So, table can be in the third normal form but still fail to meet the Boyce Codd normal form when no partial dependencies nor does it contain transitive dependencies, and a non-key attribute is the determinant of the key attribute. So, in this case what we are saying is that a table is in the third normal form, that is no transitive dependency is there, but there is a different kind of dependency, that is a non-key attribute determines the key attribute, that is a reverse kind of dependency is seen. Because in this case what we are saying is that the non-key attribute is also a candidate key. It qualifies to be a primary key, therefore it can completely determine or include the value of a key attribute. So, in a situation like this, when a non-key attribute determines the value of a key attribute, the type of normalization which will be required is the Boyce Codd normal form. So, this diagram very clearly shows here that we have a composite key which has two attributes A and B, which together form the primary key, and C and D are the non-key attributes. We see that A and B together determine C and D, but at the bottom of the diagram we see an arrow from a non-key attribute C towards a key attribute B. So, this situation where we have seen that the non-key attribute C is determining the key attribute B needs to be rectified through the Boyce Codd normal form steps. Now, what are the steps that are needed? For example, in this case we have a table where we have student number and course number as the primary key, and we have instructor number as the non-key attribute, which is determined by the student number and course number together. But in this case instructor number, which is a non-key attribute, determines course number, which is part of the key attribute. So, what is done is that from this one relation, two relations are created using the Boyce Codd normal form, where we have student number and instruction number in one relation and course number and instructor number in the other relation. Therefore, the non-key attribute is used to create two relations where it becomes a key attribute. Thus, after doing this step, that is eliminating the dependency between a non-key attribute and a key attribute, that is a reverse dependency where the non-key attribute is determining the key attribute, the relation is said to be in Boyce Codd normal form. So, finally, we have seen that the database has been normalized in the first, second, third and the Boyce Codd normal form. So, we have seen that database normalization reduces the redundancy, it increases efficiency and it eliminates anomalies. So, the first three normal forms are usually sufficient for most small to medium size applications. As I have already discussed this point, that for most of the smaller applications we do not require to go to the higher normal forms. Actually, there are 7 normal forms up to which one can normalize the database, but for most practical purposes we use to 4 normal forms, that is first, second, third and Boyce Codd normal forms. At times, exceptionally, 4th normal form may also be done. After reducing the redundancies, eliminating the anomalies, the efficiency of the database increases to a very great extent, because the data requires a lot of space to be stored. And if you have the same data stored at multiple places, which leads to anomalies and hence inconsistency in data. So, apart from having wastage of precious storage space in the databases, we also lead to inconsistency in the databases. Therefore, we say that after the process, the normalization process should always be incorporated in case of a database design. Normalization should always be part of the design process. The proposed entities must meet the required normal form before table structures are created. Many real-world databases have been improperly designed or burdened with anomalies if improperly modified during the course of time. Thus, we should always emphasize that after the relational schema phase, in case of the implementation of a database application, the database designers should always aim for normalization procedure. This will eliminate the possibilities of anomalies and at the later stage will save the database designer as well as the consumer from a lot of hassles which may result due to anomalies which will arise because of the redundancy in the databases. Normalization procedure is a simple procedure which can be easily practiced. Therefore, all the database designers are often suggested to take this extra step. Thank you. Thank you.
Thank you, Dr. Bharadwaj, and thank you viewers for watching us. And if you want to go into database designing, normalization is really a great thing for you. Thank you all for viewing.
Thank you.